Now we are going to see the third one, effect of pressure. This reaction is a homogeneous reaction. Why do we say homogeneous? All the reactants and products are in the same phase, which is the gaseous phase. Now, pressure, you have studied about it last year in Boyle's law. Whenever pressure increases, volume decreases. So here we are going to increase the pressure. If you are increasing the pressure, volume will decrease. Now let us apply Le-Chatelier's principle. What does Le-Chatelier's principle says? If you make any change in pressure, temperature or concentration, the system will opposite. So now, how many moles on the left hand side? You have got 1 mole of nitrogen and 3 moles of hydrogen. Add them together. 1 plus 3 is 4 moles of hydrogen. Go to the product side. How many moles of ammonia are there? 2 moles of ammonia. So in the reactant side, you have 4 moles, which is more number of moles compared to the product side, which has got only 2 number of moles. If you increase the pressure, the system will try to go to that side where there are few moles, so that the pressure can be decreased. Because you are increasing the pressure, the system will try to decrease the pressure. Because few moles, few collisions, less pressure. More moles, more collisions and more pressure. So when you increase the temperature, when you increase the pressure, the system will try to decrease the pressure. Then it will favor to that side where there are few moles. But if we decrease the pressure, system will go to that side where there are more moles. So it will go to the left. So now we are going to see how the concentration time graph is going to be affected because of increase in pressure. As we did in the previous examples, hydrogen concentration decreased, nitrogen concentration decreased because they are reactants. But the concentration of ammonia increases. At equilibrium, concentration of all the chemicals remain constant. Then at T2, pressure is increased. How do you know pressure is increased from this graph? Pressure has something to do with volume. If pressure is increased, means volume is decreased. What do you mean by volume is decreased? Volume is decreased means concentration increases. So all the chemicals concentration increases. If the concentration of all the chemicals increase, it is due to increase in pressure. It is due to increase in pressure. Then when you increase the pressure, which reaction is favored? Forward. So the nitrogen will decrease, hydrogen will decrease and ammonia will increase. So the product is favored. So by increasing the pressure, we can produce more ammonia. Now let's see the rate time graph. It is similar to the one that we had seen previously. It's a rate. Forward is continuous line, reverse is a dashed line or dotted line, and the pressure is increased. The rate of both forward and reverse increase, but forward is favored more than the reverse, then it attains equilibrium. When you combine all the 3 factors that we had seen, concentration, temperature and pressure, in this above process, we can decrease the temperature according to Le-Chatelier's principle. We can increase the pressure according to Le-Chatelier's principle. But we can increase the concentration of nitrogen and hydrogen and remove the concentration of ammonia. It will work. But there is disadvantage with decrease in temperature and increase in pressure. These two, they work when we talk theoretically, but when you go a practical situation, it doesn't work. When you decrease the temperature, the rate becomes very slow. So they do not decrease the temperature in the industry, they actually increase the temperature. The temperature that they use is 450 degrees Celsius. But if they use 1000, the yield will become very slow. Temperature increase, yield decrease. So this is the optimum temperature that they use in most of the industries. And when it comes to pressure, increase in pressure is also not a joke. It is a very expensive process. If the pressure becomes too high, the whole thing can burst. So you must have the whole container very strong. It is done with steel and it makes the thing expensive. So they do not use a very high pressure. Most of the time they use 450 to 500. It varies from countries to country and see depending upon the facilities available. So most of the time it's 450 to 500 atmospheric pressure. They will work it and it comes out to be very nice. Thank you.